Imagine walking through the North American wilderness 15,000 years ago. You wouldn't find the quiet forests we know today. You would be stepping into a terrifying and magnificent safari, surrounded by creatures the size of armored tanks. Standing next to a mammoth skeleton makes the scale of this era clear. Between the towering ribcage and the sweeping tusks, these giants thoroughly dwarfed any animal found in the wild today. This data tracks the global populations of megafauna, animals weighing over 100 pounds. Look at this sheer cliff edge. In a geological blink of an eye, roughly 80% of these giant species vanished from the Earth. Piles of ancient bones like these are the remains of the Quaternary Megafauna Extinction. For decades, researchers have been digging through these mass graves to determine exactly what wiped out the planet's largest creatures. Uncovering what erased these giants reveals why our modern wilderness feels so empty, and how quickly a landscape can lose its primary architects. The primary suspect for a long time was the weather. Between 12,000 and 15,000 years ago, the Earth transitioned rapidly out of the Ice Age. As glaciers retreated, global weather patterns were altered. The vast, cold grasslands known as the Mammoth Steppe, which stretched from Spain across Asia and into North America, were replaced by dense forests and wet, boggy tundras. Giant herbivores like the woolly mammoth and the giant ground sloth were highly specialized. They needed to consume hundreds of pounds of specific vegetation every single day. When the climate shifted and those food sources vanished, they simply starved. However, historical global temperatures show a major flaw in this theory. The Earth had already gone through dozens of similar warming and cooling cycles over hundreds of thousands of years. The megafauna survived all of them, their populations remaining steady through every previous spike. Since these populations had already survived dozens of identical warming cycles, the climate shift at the end of the last ice age was clearly missing a critical, lethal component. This map shows human migration routes at the end of the last ice age. As modern humans expanded out of Africa and Eurasia, they crossed into Australia and the Americas. For the massive animals living there, Homo sapiens was an entirely new, cooperative apex predator. If we track when local megafauna populations collapsed, those die-offs line up suspiciously well with the exact moment human bands arrived in those specific regions. In Africa, animals evolved alongside hominins for millions of years and learned to avoid us. But in the Americas and Australia, these giants had never seen a human. They had no evolutionary instinct to run, making them easy targets. These hunters were also highly advanced. Armed with atlatls and ration-sharp flint points like these, early human bands could take down even the largest mammoths. The real issue was biological math. Giant mammals reproduce slowly, often raising only a single calf every few years. Hunters didn't need to slaughter entire herds. Picking off just a small number of adults was enough to drive a population into an irreversible decline. Some researchers have proposed the hyperdisease theory, the idea that humans inadvertently brought novel pathogens with their domestic dogs and rats. This would have caused immense immunological shock to isolated animal populations, though proving it remains difficult without clear evidence in the fossil record. While human hunting was a lethal trigger, the sheer totality of an 80% global wipeout suggests that human arrival alone was not the entire mechanism. Today, most scientists point to a combination of climate change and human hunting that triggered a total structural collapse of the environment. Megafauna were keystone species. Mammoths acted as ancient bulldozers, constantly knocking down trees and trampling saplings. This behavior is what kept the plains open and maintained the vast grasslands. This pyramid shows how an ecosystem relies on its foundation. When human hunting and climate stress combined to reduce the mammoth population, the bottom layer of the ecosystem was severely weakened. This triggered a trophic cascade. Without mammoths clearing trees, forests choked out the grasslands, permanently destroying the habitat for other grazers. As that food supply vanished, the middle layers of the ecosystem collapsed. Without herds of grazers, the top of the food chain fell next. Even predators with massive fangs, like the saber-toothed cat, rapidly starved to death. The entire food web gave way, leaving the giants with no habitat to graze and the predators with no herds to hunt. When you look at the modern wilderness today, You are looking at haunted landscapes, vast, quiet environments, missing the giant architects that engineered them. The Quaternary Megafauna Extinction reveals the underlying fragility of natural networks. An ecosystem that has thrived for hundreds of thousands of years can shatter if you remove just a few key species from the board. This collision of a warming Earth and a new apex predator removed 80% of the world's large mammals in a few thousand years, a specific documented warning about how quickly an ecosystem can unravel.